In this video, we're going to use substitution to evaluate a definite integral with trigonometric functions. It says if you were to use a substitution of u equals cosine x to evaluate the definite integral below, what would the new limits of integration be? So if we say that u is equal to cosine x, and then we wanted to find because these two bounds are for the x variable. So if we want to find the new bounds for the u variable, what we do is we come over here and we say u is equal to cosine. We substitute pi over 4 in to find out what u would be when we have an x input. And then we do the same thing when we say u is equal to cosine of pi over 2. So when we do cosine of pi over 2, that is 0. So u would be 0. And we do cosine of pi over 4. Cosine of pi over 4 is root 2 over 2. So when we rewrite this integral, we would say integral from 0 to root 2 over 2. And then we would have 2 sine x cosine, not cosine, u to the 4th, because I'm substituting u for cosine x, dx. So I answered the question here. The question was, what are the new bounds? 0 and root 2 over 2. Those are your answers for this problem. But I'm just going to go ahead and finish the integration here, just for fun. And we would say that u equals cosine, we do d over dx of u is equal to d over dx of cosine x. So then we take the derivative of u, so we get du over dx is equal to the derivative of cosines, negative sine x. And then multiply by dx, so we get du equals negative sine x dx. Divide by negative sine x, so du over negative sine x is equal to dx. So then we're going to do some substituting here. Let's substitute du over negative sine x into this function for dx. So we get the integral from 0 to root 2 over 2. And we would get 2 sine x u to the 4th over 1 times, when I substitute this piece for dx, I get du over negative sine x. The sine x's are going to cancel, and I'm going to get negative 2 there. So integral 0 to root 2 over 2, negative 2 u to the 4th du. So then I'm actually going to do the integration because I want to show how you use the bounds, the new bounds. We do the integration here, and we get this to be equal to, add 1 to the power and divide. We get negative 2 u to the 5th divided by 5. And we're going to use the bounds 0 to root 2 over 2. So we're going to evaluate this from root 2 over 2 to 0. So we would end up with negative 2 root 2 over 2 to the 5th divided by 5 minus negative 2 times 0 to the 5th over 5. So you can see this piece is going to cancel. And if I do some simplifying here, take this to the 5th power. So this is really the 1/2 power to the 5th power would be to the 5/2 power. So I end up with, let's see, negative 2 times, this would be 2 to the 5/2 power over 2 to the 5th power, which is 32, divided by 5. Let's start to simplify that. We'd end up with negative 2 times, I'm going to say that this is really 2 to the 5th, then to the 1/2 power. And then this 32 that's in the denominator is going to combine with this 5 here. So 32 times 5, 160. 2 and the 160 are going to cancel, so I'm going to end up with negative 1 here, and divide this by 2, and I end up with 80. So I have negative 2 to the 5th. So if I'm taking the square root of that, I can actually take 2 sets of 2 2's. So this would be like 2 squared. Actually, let's write that. This is 2 squared times 2 squared times 2, all to the half, divided by 80. So I can write that that's equal to the square root of 2 squared would be 2. So I end up with negative 2 times, same thing here, square root of 2 squared would be 2. And then I get root 2 over 80. I can divide this by 2 twice, so this will cancel to be, both of these will cancel. I'll divide this by 4, I get 20 down here. So I get negative root 2 over 20. And I went a lot farther than I needed to. All I needed to do was find the 2 bounds, but I wanted to show how the bounds work when you go to do this integration. We're used to substituting cosine x for u here, but because we found new bounds, we don't have to do that. We can just plug the stuff in for u and get our area.